This is the second half of the two-step equations video, and in this video we are going to learn how to solve two-step equations that have multiplication first. Okay, I like to call this set type 3 two-step equations. They are a completely different style than what we did in the last video. We're going to start with multiplying first, and then we are going to end by adding or subtracting. The reason that we have to multiply first for these types of two-step equations is we can't get rid of this number that we're used to adding or subtracting because it is stuck in the top of our fraction. So that means that before we can use it, we have to get rid of the stuff that's on the bottom. Basically, we have to get rid of the fraction before we can do anything. So to get rid of the fraction, which remember this line here also means division, we're going to do the opposite, which is to multiply by the number on the bottom. In this case, it's 5. So the 5 and the 5 will cancel each other out, which means, oh look, fraction is gone. Now I can work with the stuff on the top of it. And 3 times 5 is 15. To get rid of this number here, the opposite is to minus 2 from both sides. Remember that makes 0. And 15 minus 2 would then be 13. So this is p minus 13. Okay, second example, n minus 1 over 7 equals negative 3. Again, remember, I'm going to multiply on the second example, n minus 1 over 7 equals negative 3. Again, remember, we can't do anything with the top yet, so we're going to multiply by the number on the bottom to be able to get rid of the fraction. One common temptation that I will see people do after they multiply is to end up multiplying to everything in the top and end up with something that looks like this. Now, be careful not to make this mistake. It is not something that is needed to do because these are already opposites of each other. Our goal is to cancel stuff out. We are not ready to do distributive property yet, and you don't have to because there's no parentheses up there. So we would just have n minus 1 left over, and then equals, that would be negative 21. To get rid of the minus 1, we'll add 1 on both sides. Those cross out. And negative 21 plus 1 is negative 20. So the final answer for this one is negative 20. Last example, 4 equals 1 plus b over 3. Remember, if you have stuff that's backwards, you can still do it the exact same way as the forward ones, or you can flip it. Either way, you'll end up getting the same answer. Doesn't matter. So the 3's cancel out because they're opposites, but 3 times 4 makes 12. So now I'm left with 1 plus b. I need to put these two together. This is a positive 1, so I'm going to subtract 1 from both sides. Those make 0, which means I can bring the b down. And then 12 minus 1 is 11, so 11 equals b, or b equals 11. Whichever way you want to write it is totally fine. Okay, these two equations I like to call type 4 two-step equations. They also start with multiplying. They then use addition or subtraction, and then finally more division. So these are actually more like 3-step equations, but I include them in the 2-step equations because there's really only one extra step. So when we look at these ones, the first thing we're going to do is multiply, because notice that this looks a lot like distributive property, so we're just going to get rid of the parentheses. So that means we got 9 times a, which is 9a, and 9 times 5, which is 45. And the minus 27, excuse me, the negative 27 will stay the same because it's not part of the parentheses, so we don't have to multiply to it. Now our next step is to go back to addition or subtraction. This looks a lot like our type 1 equations. We're going to put these two together because they are like terms. The opposite of negative, or the opposite of positive 45 is negative 45. So that means I will be subtracting on both sides. Those make 0. Which means I can bring down the 9n. Negative 27 minus 45 is negative 72. Now to get rid of the 9, remember there is invisible multiplication here. So if you need to write it in, you can put that dot there, but then we'll end up dividing by 9 on both sides. That's gone. And we are left with a equals negative 8. For our final example, we've got negative 4 times negative 8 and negative 4 times negative k equals 12. Negative 4 times negative 8 is positive 32. And negative 4, we're going to imagine that this is like a negative 1k, would be a positive 4k equals 12. Okay. We're going to start again by getting our matching numbers together. This is a positive 32, so that means I'll want to subtract 32 from both sides. Oops, those make 0. We got 4k by itself, and 12 minus 32 is negative 20. Finally, we will end up dividing by 4 on both sides. The 4's cross out. We now have k by itself, and negative 20 divided by 4 is negative 5. Final answer. Thanks for sticking with me through these 2 videos, and contact me if you have any questions.